Alright folks, my plan was to make 3 video segments for the design table using the approach that I've adopted since last year instead of the older ones, which is different. But we were in the midst of doing that in the classroom and there was a power outage. So I'm gonna do this problem first as a design table problem. You may want to screen capture this so that you can see what's going on. And then after I'm done with that, I'm going to create another segment which deals with parameterizing this. In fact, I was not intending to do this thing as a design table in the class. So I did it as a parameterized model, but that's when we lost power. Okay, so I hope you capture the screen. Let's go ahead and do that. This thing actually can be found on some of the segments that I made a year ago, but the way I've done it it may be different, and in fact, yeah. So it's up to which one you want to follow. All right, let us start with the part, and immediately we're going to save this. So file, save management, save as, desktop, new folder. I'll call it problem 4. Okay, so we stop this. Now we're going to make a nominal part like it is on the screen. It was on the screen in that loose sheet. So let me do it like this. That's the left side or right side. This is the left side. On purpose, I'm not making these things symmetric. So now we can make it symmetric. So for example, this line controls that line and the middle segment. And remember, this is the important dialog box. We're going to make it symmetric. And this line control that line, control this line, the axis, also symmetric. All right, very good. Now notice that we can change this thing at our will, and it's going to change. Now, there are some dimensions that are specified. This guy and that guy, oops, not this. Let me delete that. Dimension between that axis and this is, you're told that this is always 5 inches. So let's give it a 5. That's okay. So that this doesn't distract me. So we're going to move in. Okay, and dimension between that edge and this edge. Let me delete this. Dimension between the axis and this edge is also 5 inch. Now, are these millimeters? Oh, maybe that's what it was. I'm sorry. This okay. Let me change this thing to 5 inches. My units were in millimeters. That's why it looks like that. And let me make this thing also 5 inches. Okay, very good, very good. Okay, so as a matter of fact, let me go and change my units to inches so that I don't have to worry about this issue anymore. So tools, options. You know how to do that. Parameters and measures, units, length, I want it to be in millimeters. I usually work in inches. The only reason I turned to millimeter because I made that crash course video segment for you where units were changed to millimeters. Okay, good. Now, let's see now. We have, we're going to draw a circle here, centered at the origin like that. And this is going to be a construction circle because the center, the purpose is that the center of these other 2 smaller circles are in fact on that one. This is not the construction one, so I'm going to turn it into a geometric entity, drawing entity, and this one. All right, good. Now let's put some dimensions that eventually are going to become parameters here. Or let me see. It's going to be things in my design table. Let's not call it parameter because parameter has a different meaning, and you're going to see that after I finish with this clip. So that's going to be, if you look at the loose sheet, this is going to be called R. Oh, sorry, not R. Cancel that. We're going to rename this thing to R later on. So I just put a dimension right now. We're going to do the renaming all at once. So what is that? This is going to be later called R1, and this one R2. This angle is going to be alpha, and this angle is going to be beta. All right, exit, pad it. Where's the pad? Or right there. Okay, let's apply a dummy material on this. So metal, aluminum on this part body or on part. All right, we're good. Now we're going to start doing the renaming stuff. So click on it, click on f of x, click on the part. This guy, these files do not change. Let me start with the angles. So this one is going to be called beta. Okay, so that angle is going to be called beta. Apply. This other angle is going to be called alpha. Apply. Let's see where else have we got. This guy, this is the radius of the construction circle. You can see that like this. Okay, so this is going to be called R. Apply. And this one on the right, this is going to be R1. Apply. And the one on the left, this is the radius on the left, that guy, is going to be called R2. Apply. Now I also want to rename the material and the part name. So what I usually do is I go and filter this thing with the strings. So there is the part material. So I'm going to change this to my math. Apply, and there's a part number. I'm going to call it my name. Apply. I think that's pretty much it. Once we do all the renaming, okay. Once again, I'm going to emphasize that if you look at some older video segment, you're going to see that the material and part name are not done like this. Okay, they're not renamed, and therefore have to force association a different way. If you look at those, you realize that there's a difference. Okay, then you go to the design table right there. You see this? Click on it. We're going to create a design table. We don't have a pre-existing one. And the stuff that you want to put in the design table, I'm going to say, show me filter it according to the rename stuff. The first column is going to be part name. Second one is going to be math. Then according to the table, when I say this table, I mean this table. R1, R2, R, R1, R2, R, alpha, and beta. And then it says, where do you want to put it? Obviously, I want to put it in problem 4 folder. Now, before I do any more work, I'm going to save this thing because I didn't even save my part. I don't think I have. Anyway, it's right here. You can close this, okay? The design table is right here. Oh, where is that? Not there. It's right there. You can see that. It's right there. And if you don't have this thing, if you cannot see it on the screen, you can activate it. Go watch the crash course video. Okay, good. So let's save everything. File, save management. I'm not sure if I actually did put it in there. Modified. I guess I did actually originally put it in that folder, problem 4 right there. So we say okay. I could have clicked on the floppy disk here and it would have done it automatically. Okay, now let's go back to the design table. Edit the table. There is the table that I created for you right there. So the first column is the name of the part, and then R1, R2, etc. So let's fill in that table. 1A, brass, 0.5, 45. I'm hoping that these numbers are all correct. Correct meaning that they will not give you a self-intersecting curve, etc. If they do, then we can go and change it. Ordinarily, when I do a problem like this on a test, I avoid doing a mistake like that, but it occasionally happens, so we're going to check it. 2 and 45 and 45. Okay, there may be some problem with these dimensions, as you see. 2A. Okay, copper. 0.25 and 0.5. Radius is 3, or is 3, and then there's 90, and then there's 90, and 3A is going to be silver, silver. Then 0.1, 0.25, 4, 90, and 30. Alright, so save everything and close it. Wait for the report dialog box to show up. This is the knowledge report. No errors here, so that's okay. And now let's check it out. So this was the nominal one that I created. Okay. If you go to the next row, notice that the part name changes, the material changes, and hopefully it's not self-intersecting. Okay, that's good. That's good. You go to the next row. Part number changed, material changed, and apply. There we are. No problem there. Last one. Apply. There. So I did this problem from A to Z using design table, the new approach that I'm using this here instead of the parametric form. Okay, so I'm going to repeat this problem as a different video segment where I parameterize that same problem. All right. So let me close this.